Okay, so first to solve this differential equation, we're going to put it in the standard form. So we're going to do y prime minus 10x times y equals y to the 4 times cosine x. And because we have that y to the 4 term, we're going to do Bernoulli's transformation. So we're going to use Bernoulli's equation. Okay? And you remember what Bernoulli's equation is saying? It's saying make the transformation from u to v such that v is equal y to the 1 minus n, where n is the power on the y on the right hand side. So in this case, n is 4. So then we're going to make the transformation of v being y to 1 minus 4. So that means v equals y to the minus 3, which means v equals 1 over y cubed. Okay? And if that's the case, then we also have to figure out what to do the transformation what y prime is. So we know from that equation that v so we can find y, so y is equal to raise this to the minus 1/3, so v will equal to the cube root, or y will equal 1 over v cube root, which is the same thing as v to the minus 1/3. And we will find dy over dx is equal to minus 1/3 v. Minus 1/3 minus 1 is minus 2/3, power rule, and then we will multiply by the chain rule the derivative of v, which is dv over dx. Okay, and now we're gonna substitute into the original differential equation. So let's do the transformation. So now y prime is just minus 1/3 v to the minus 2/3 dv over dx minus 10x times y, and y is just v to the minus 1/3 equals y to the 4. We just raise v to the minus 1/3 to the 4, so it becomes v to the minus 4/3. And now we can multiply this to put it again in the standard form. We can multiply it by minus 3 v to the 2/3. So we can make this term here a 1. So this equation becomes dv over dx, because minus 3 times minus 1/3 is minus 1. Oops, wait a second, there's a mistake here. Minus 1/3 minus 1/3 minus 1 is minus 4/3. So this will have to be minus 4/3. Okay. So we need to multiply by minus 3/4. Okay. Okay, so then we get this to be 1 dv over dx minus, if we multiply here by minus, becomes this is a 3 tan x, and then v to the minus 1/3 times v to the 4/3 is just v, equals, oh, on the right hand side we have a cosine x here. Okay, so when we do this, we get minus 3 v to the minus 4/3 times v to the 1/3 is v to the 0, which is 1, so we just get here minus 3 cosine x. And now we can do this using an integrating factor. So so let's multiply this by mu, this by mu, and this by mu, with mu of x being the integrating factor. So after we do the transformation, we need to use the integrating factor method to solve it. So then the right hand side of this is just d over dx of mu v has to equal minus 3 cosine x times mu. Okay, now if we carry on the product rule, this will be mu dv over dx, which is the same thing as this, plus v times mu prime equals minus 3 cosine x times mu, which is the same thing as this. So if these two equations are to be the same, that just means the middle term has to be the same, which makes mu prime has to be the same thing as 3 tan xv. So that means d mu over dx has to equal 3 tan x times mu, separation of variables, so d mu over mu will equal 3 tan x dx. And now we can put integral signs here and here to carry over the integration. Okay, and we get ln mu equals, the integral of tan is, we can say this is sine x over cosine x, so we can call cosine x u, so sine x will be minus u du, so this will be 3 ln cosine x, minus sign coming from the derivative of cosine x. So that means ln mu will equal ln cosine x to the minus 3. So that just means that mu of x will equal cosine x to the minus 3, which is the same thing as 1 over cosine cube x, which is the same thing as secant cube x. So our integrating factor is secant cube x. Okay. So now we're going to plug that back in there. So we're going to get d over dx of v times secant cube x is equal to, so I'm plugging this here on this one, minus 3 cosine x by secant cube x. And now what we will do is put an integral sign on both sides after we move this dx here, and the integral will undo the derivative, and we will get v times secant cube x equals minus 3. Now secant cube is 1 over cosine cube x, so this will cross out a cosine and we will get minus 3 integral of secant square x dx. And the integral of secant squared is tan x plus c equals to v secant cube x. And now to get v, we just divide by secant cube. So we get minus 3 tan x over secant cube x plus c over secant cube x. Now tan is sine over cosine and secant is 1 over cosine. So one of the cosines goes away and we get minus 3 sine x over secant square x plus c over secant cube x, and that's v. But we are not looking for v, we're looking for y. However, we do know that y is v to the minus 1/3. So we can just plug that in. So since y is equal v to the minus 1/3, then y will just equal this whole thing raised to the minus 1/3. Secant square x plus c over secant cube x raised to the minus 1/3. And this is the solution of the differential equation using Bernoulli's transformation from y to v and using the integrating factor method. Any questions on that then?
How did it start out? What would you do with B?
1 second here. What do we do with v? We take the, once you find v, you can find dv over dx,
Right,
or
right.
dy over dx, and we plug it into the original differential equation.
Yeah.
Okay? And you take its derivative.
So